About getting insights into data is fantastic. For the first time, we are managing 1.5 million databases. For the first time, we get to see how our algorithms are working out, how we can improve them, what is really practical, how can we predict. And we learn all of this stuff. We're learning so fast every day, every week, out of the 70 terabytes that we collect every day. And we're getting smarter about making this better. Because when we talk about this phenomenal amount of growth of data, we're not going to have so many DBAs that are getting more employed every year. We don't have enough DBAs to keep up with all that data. And so we have the double challenge of being able to create new software technologies to be able to handle all these volumes of data, different types of data, but also make it simpler and simpler to cope with standard well-known techniques. So you will see us do both. Make it simpler based on our deep insights and make it more capable because of new capabilities. But let's come back to the core. All of this is built on the foundation of SQL Server. SQL is the most beautiful thing ever built. It's a very simple way to ask a very complex question, very precise question, for which you get precise answers. There's just a world of technology underneath. And SQL Server 16 is the greatest release that we've ever done. And we're very excited by that. It is focused on three major areas. Of course, across the entire product, there are changes. Every part of the product, including analysis services, IS, reporting services, everywhere, we're making improvements. But there are three major areas of investment that we consciously think through. And the first one is mission critical performance. Because as we mentioned before, this stuff has to work reliably and reliably all the time. That is secure, that's scalable, and all of that stuff. And the second is true to our mission. Get insights from this data, and we have some very important investments there. And the third is the hyperscale cloud, the hybrid nature, how to adopt the cloud in very sensible ways, in ways that make sense to you, that are most appropriate for you. So let me give you just the highlights, and this is not the comprehensive list. The full list you can find in various places on the net, but this is a set of few things. I'll just call attention to a few of these highlights. On the mission critical side, one of the things that's very exciting for me is the query data store. Now, this is something that we learned running 1.5 million databases in the cloud. And this is a simple database of every query, how long it took, what the plan was, and how the execution happened. And for every query, every database. Now, this is built into the database. We're now baking it in the cloud. We're using it ourselves. What Sanjay showed in terms of the index hints is based on the query data store. And this is something that will be part of SQL 16. The next big thing is we made Polybased Technology available. So this enables you to go from T-SQL and then be able to reach into Hadoop systems so that you can do uniform queries, joining between what's in SQL and what's in Hadoop. And this is a technology that we've had in our APS system, and now we're bringing it to the SQL 16. Another big thing that coming to the hyperscale cloud is Power BI. Power BI, even while it is a SaaS platform, it is able to work against on-premise SQL. So now you get value from the cloud for your on-premise systems. We also have Data Zen that's available. And so I will talk a little bit more about the highlighted ones in the next few minutes. So it's a fantastic release. We're making widespread improvements across the board, and we're making key investments in three major areas. Let's look at a few more of them closely. Operational analytics, in-memory enhancements. Now, for the longest time, we've had this familiar pattern where we have OLTP systems, and in the OLTP systems, there's the data that runs your business, and then we extract that data with ETL to data warehouses, and then in the data warehouses, you do some analysis. So let's say we wanted to do some fraud detection, and you would run these queries, analysis queries, against the data warehouse of sorts, and then be able to detect which ones are fraudulent, and then you take actions on them. Now, as you know, we have had leadership in two big areas. One in-memory OLTP with the SQL 14, and the third generation of in-memory Columnstore from Vertipack that we released a while back. Now, we are now in SQL 16, we're combining these two capabilities. You can now define in-memory indexes, the column indexes on all sorts of raw data. Now, this enables you to combine both sort of workloads, both OLTP and analytics queries in the same system. So in the same system that's scalable to 120 cores with Dragonhawk, you can run both types of workloads. With the result, you can do the real-time fraud detection, you can do the analytics at real time in a scalable manner, and then be able to take actions on the transactional systems. And we believe that this is going to dramatically simplify on-premise environments. Instead of having multiple systems and having data move from system to system, you collapse and make it one system that's able to handle both types of workloads. And this is a dramatic improvement, we believe, and we're in the leadership position on both OLTP and analytics, and we're combining them together. And so that's a very important mission-critical capability that we're rolling out in SQL 16. The next interesting one is on security, and we call it always encrypted. Now, as you know, data is ordinarily kept in the clear in the database, even though it is encrypted on disk and so on. And so you can see social security numbers. And think of ID columns. This is the most important characteristic there. It's a precious property. And this information is kept in the clear ordinarily. And what we're doing with this capability is to assure people that such ID columns that you designate will be always encrypted. So the way we do that is we take client-side, we've enhanced the client-side libraries, which then encrypts that ID field and keeps it in ciphertext. So well before it hits the server, the client driver is able to encrypt it and then keep it in encrypted form in the database. So if you look at the database, including the DBAs, if you look at the database, you'll see only the ciphertext. You know it's social security, but it's ciphertext. Even the column encryption key is encrypted by the client. So if you have a query that comes, the apps do not have to change at all. The query is a simple query, select from there where the social security number is something. The client side then encrypts the query request and then sends it over, and which then comes to the SQL server. It looks like the gobbledygook. Social security number is this encrypted form, which of course beautifully matches what's in the database. Oops. And which then finds the record and then returns that record back to the client. And on the way back, it gets transferred properly. Now, the beautiful thing with this is the data is encrypted in the client, therefore in transit, in storage, in memory on the server, everywhere it is always encrypted. And this is something that we have done. And the beauty of this is the applications do not have to change at all. You just declare this to be always encrypted and you get the benefits. It is done completely transparently because we have improved the client side to make it all transparent. So it is security and very simple mechanism to use that security. We think this is going to be dramatically valuable. There are lots of places where it can be used. Of course, it can be used on premises with separation of concerns, and it can also be used in the cloud. And so this is a very exciting thing for us, mission critical capability. Let me switch to the next one. Insights from data. As you are well aware, there's a set of professionals, data science professionals, who have been working on R systems for a long time. And they have figured out ways by which, with a collection of data, they can get deep insights using R in machine learning, in statistical analysis, and so on. And what we're doing with this capability is to bring that deep inside database. And the way we're doing that is enable our scripts to be able to run directly on SQL Server data by being very close to the SQL Server. So we can take our scripts and then be able to execute it in the path of transactions, in the path of queries. Now this enables data scientists to contribute their knowledge in R, and then for DBAs, SQL professionals, to be able to harness that. And the beauty of that is how we use the cloud. In the cloud, we have the marketplace, and where the data science folks keep publishing their R packages, and database folks can take those R packages and be able to then install them in SQL Server and be able to take advantage of them. So here's another case where cloud is enabling new value in the same SQL Server over time. As the community develops more and more R capabilities, you can make them all available to database applications. And so here's a little example for credit risk protection that is newly rolled out from the marketplace. And so this is a beautiful integration. You're adopting the cloud by providing value on premise. And so this is an important one that I want to call attention to. And the last one that I would say is what we call stretch. And this is very exciting for us. And so, you ask yourself the question, we have on-premise database systems, and we have this hyperscale cloud. When there's so much capability that's available in the cloud, is there any way for us to take advantage of that, even for on-premise? And our answer is the stretch capability. So fundamentally, what it enables you to do is to take warm tables and cold tables, and then be able to keep only the most recent data on-premise, and then stretch the rest of it to the cloud. And so you look at something like order history, which is always accumulating, and then you're able to say, click the order history table for stretching purposes. And so the logical view is that this table is now stretched from on-premise to the cloud. What is really happening behind the scenes is that some of the data that's old is getting pushed over to the cloud. And whenever there's a query comes, the application does not have to change at all. This keeps asking the same kind of questions over the full set of data. And whenever the data is remote in the cloud, the query gets separated out, and a separate part of the query gets sent to the cloud, and the results get brought in, and then the full results are compiled, provided to the client. And so it is a completely transparent capability to use this data. So let's take a step back and think about what this means. What this means is every database is an infinite database. What you have on premise is only a small part of it, the most recent part of it. You never have to throw out data. You simply have to flow it to the cloud, and all processing happens transparently, automatically, without any change to applications. And we believe that this has tremendous potential for future applications. And this is fantastic. So let me now ask, this is a little animation here showing that the query from the application goes to the cloud and then returns the result. Let me ask Ajay to come up and demo a few of these capabilities for you.